I'm Yep-Ming Chang. I'm a co-founder of 24M, and I'm also a professor in the Material Science and Engineering Department at MIT, where I've been teaching for over 30 years now. I've been doing research in batteries for about 25 years, and 24M is the culmination of a lot of things that we learn, both in research and in the industrialization of new battery technologies.
I'm Rick Felt. I joined 24M about 7 months ago now. I'm the company's CEO. I've got about 40 years of high technology experience, mostly in companies that design and make products. And I thought this was a great opportunity to join Yet and team because I think 24M is just at that transition point, ready to take off into substantial commercialization. That's why I'm here.
Lithium-ion batteries are today's most advanced battery technology. The technology is about 26 years old now, and first developed in the late 1980s in Japan, and has come to dominate all aspects of our technological lives, from handheld devices to electric vehicles, and increasingly for grid energy storage. Right? And there are a lot of good reasons for that. It has a material set that has very high energy density, stores a lot of energy for the volume or the mass that you have. Delivers high power, lasts a long time. But as a technology that's now a quarter century old, what has carried along over the last 25 years are the original ways of designing and building that lithium-ion battery. And over the last quarter century, some of the less efficient parts of the manufacturing process have really persisted. And having earlier developed a battery technology that was a new chemistry and was put into commercialization, but manufactured the conventional way, I had learned a lot about what the weaknesses of the conventional manufacturing approach were. And so 24M is a company that we formed to remedy those deficiencies. In short, what we do at 24M is we have developed both a cell design which makes much more efficient use of the materials that go into a lithium-ion battery. And specifically, it decreases the amount of material that does not store energy. We maximize the amount of energy storing materials, decrease all other materials, and in that way we lower the cost of materials for the entire battery. Right? And so that's one key aspect of our technology. Along with that, however, we've also developed a new manufacturing method. And this manufacturing method strips out a lot of the methods, the unit operations of the previous manufacturing method. We have about 1/3 the number of unit operations in our manufacturing approach. It speeds up the time to produce a lithium-ion battery. It decreases the footprint to less than half the factory footprint for conventional lithium-ion batteries. Right? It removes, for example, the need for any organic solvents. And so conventional battery manufacturing uses organic solvents that are evaporated and then have to be recondensed. And so we get rid of these solvents that are unpleasant and in certain parts of the world are being phased out. By not having these steps that were used earlier, we also decrease the energy consumption of our manufacturing method. Okay? So for example, we have no drying processes in our manufacturing. Drying takes a lot of thermal energy. And then if you're drying an organic solvent, what you then need to do is to recondense and capture that organic solvent. Also very energy intensive. So overall, we have lower materials costs, we have a faster process, a smaller factory at lower cost, right? And overall for the battery cells that we produce, a significantly lower cost compared to today's lithium-ion, and also where today's lithium-ion is headed along the conventional technology track.